Howdy. I'm just some random nude dude sitting in the closet talking to myself. It's also where I celebrate the power of free thinking and encourage bold ideas. As a society, we're often afraid to challenge the norms and think outside the box. But here, I embrace the unconventional. So sit back, relax, and join me on this journey of exploration, where we embrace our inner nude dude and push the boundaries to discover new perspectives. Space travel has long captured the human imagination and led to countless works of science fiction that depict journeys to distant stars and galaxies. While many of these ideas may seem far-fetched or even impossible, recent advances in our understanding of physics and the universe have sparked renewed interest in the concept of faster-than-light, or FTL, travel and traversable wormholes, or stargates. The idea of traveling faster than the speed of light has long been a staple of science fiction. But it wasn't until the development of Einstein's theory of relativity that we began to understand the implications and challenges of achieving such speeds. Similarly, the concept of traversable wormholes, which were first theorized by physicist John Wheeler in the 1950s, has captured the imagination of scientists and science fiction writers alike. In this video, we'll explore the feasibility of FTL travel, traversable wormholes, and the challenges and unknowns that would need to be addressed in order to make these ideas a reality. We'll also discuss the potential benefits and drawbacks of this technology and examine the current state of research in this field. So buckle up, engage the inertial dampeners, and get ready for a journey through the mysteries of space and time. Can we really travel faster than light? According to Einstein's theory of relativity, the speed of light is the ultimate speed limit in the universe, and no object can travel faster than this speed. The closer an object gets to the speed of light, the more energy is required to accelerate it further. As an object approaches the speed of light, its mass increases, which makes it even harder to accelerate. This means that it would take an infinite amount of energy to reach the speed of light, making it impossible to achieve. Despite this, there have been many speculative theories and ideas proposed for bypassing the speed of light limit. One popular idea is the concept of a warp drive, which is based on the idea of bending space-time rather than traveling through it. By creating a warp bubble that compresses space in front of the spacecraft and expands it behind the spacecraft would effectively ride a wave of space-time, allowing it to travel faster than the speed of light relative to the surrounding space. Another idea is the use of exotic matter or negative energy to create a wormhole, which is a hypothetical shortcut through space-time that could allow a spacecraft to travel vast distances in a matter of seconds. By creating a stable wormhole, spacecraft could theoretically travel through it to reach a destination without exceeding the speed of light. However, while these concepts are popular in science fiction, there is currently no experimental evidence to support them. Furthermore, they rely on many hypothetical and unproven assumptions, such as the existence of exotic matter or negative energy, which are not yet understood or observed in nature. Despite these challenges, some scientists and researchers continue to explore these ideas and technologies, driven by the possibility of unlocking new frontiers in space exploration. Traversable wormholes are a hypothetical concept in physics that suggests the existence of shortcuts through space-time that could allow for faster-than-light travel. A wormhole is a tunnel-like structure that connects 2 points in space-time, which can be thought of as separate mouths of the wormhole. Traversable wormholes are a type of wormhole that can be used for travel, as they allow objects or information to pass through them without being destroyed or lost. One of the most intriguing aspects of traversable wormholes is that they could potentially allow for instantaneous travel between 2 points in space-time. This would make it possible to travel vast distances in a short amount of time, which could revolutionize space exploration and travel. Traversable wormholes are a hypothetical concept in physics that suggests the existence of shortcuts through space-time that could allow for faster-than-light travel. While the existence of traversable wormholes remains purely hypothetical at this point, scientists have proposed various mechanisms for creating and stabilizing them. One proposed mechanism for creating a traversable wormhole involves using negative energy or exotic matter to warp the fabric of space-time. Negative energy is a hypothetical form of energy that has negative mass and negative pressure, which could be used to stabilize the wormhole and prevent it from collapsing. Exotic matter, on the other hand, is a hypothetical form of matter that violates the energy conditions of classical physics and could also be used to stabilize a wormhole. Another proposed mechanism involves creating a wormhole by exploiting quantum entanglement, which is the phenomenon where two particles can be connected in such a way that their properties are linked, regardless of the distance between them. By creating two entangled particles and then separating them over large distances, one particle could be sent through space while the other remains on Earth. The particle in space would then be used to create a wormhole, which would allow for near instantaneous communication or travel. However, these proposed mechanisms for creating and stabilizing traversable wormholes are still purely speculative, as they rely on many hypothetical and unproven assumptions. Furthermore, even if it were possible to create a traversable wormhole, there are still many challenges and risks associated with using it for travel, such as the potential for extreme gravitational forces and the risk of encountering unknown or potentially dangerous phenomena. Despite these challenges, some researchers and scientists continue to explore the possibility of traversable wormholes and their potential applications. For example, some scientists are investigating the potential for using wormholes for quantum teleportation or communication, which could have significant implications for information technology and security. Overall, while the possibility of traversable wormholes remains a fascinating and intriguing concept, it is still a long way from becoming a reality. Nonetheless, the study of traversable wormholes and their potential applications continue to inspire scientists and researchers to push the boundaries of our understandings of space-time and the universe. While the possibility of faster-than-light travel through traversable wormholes is an exciting concept, there are many challenges and unknowns that would need to be addressed before such technology could become a reality. Here are some of the main challenges. Creating a stable, traversable wormhole would require an immense amount of energy. The energy required to create a wormhole is proportional to the mass energy equivalent of the wormhole's throat, which is the narrowest point in the tunnel, where the curvature of space-time is the greatest. The energy required to create a stable, traversable wormhole would need to be on the order of several stars' worth of mass energy, which is beyond our current technological capabilities. One possible way to generate the necessary energy is through the use of exotic matter or negative energy, which have hypothetical properties that could facilitate the creation of a wormhole. According to some theoretical models, exotic matter could have a negative energy density and generate repulsive gravitational forces, which could counteract the attractive forces of ordinary matter and create a stable wormhole. However, the existence and properties of exotic matter or negative energy are still purely theoretical and have not been observed in nature. Another possible source of energy for creating a wormhole is through the use of a black hole. According to some theoretical models, it may be possible to manipulate a black hole's property to create a traversable wormhole. However, this approach would require advanced technology and a thorough understanding of black holes and their properties, which are still poorly understood. The energy requirements for creating a stable traversable wormhole are enormous and currently beyond our technological capabilities. Theoretical approaches involving exotic matter or negative energy, or the use of black holes, may hold some promise for generating the necessary energy, but they are still purely speculative and would require further research and development. Exotic matter is a hypothetical form of matter that has properties that differ from those of ordinary matter. According to some theoretical models, exotic matter could have negative energy density and generate repulsive gravitational forces, which could counteract the attractive forces of ordinary matter and create a stable wormhole. One type of exotic matter that has been proposed is known as negative energy. Negative energy is a concept in quantum mechanics that arises from the Heisenberg uncertainty principle, which states that the energy and time of a particle cannot be measured with complete precision. Negative energy arises when the energy of a system is less than its minimum energy, which would correspond to a negative value for the energy of a particle. Another type of exotic matter that has been proposed is known as phantom matter. Phantom matter is a hypothetical form of matter that has negative mass and is believed to exist in the form of dark energy. According to some theoretical models, phantom matter could generate repulsive gravitational forces that could be used to create a traversable wormhole. However, the existence and properties of exotic matter are still purely theoretical and have not been observed in nature. Scientists are actively researching ways to detect exotic matter and study its properties, but more research is needed to understand how it could be used to create a traversable wormhole. Gravitational forces are one of the fundamental forces of nature that govern the behavior of matter and energy in the universe. In the context of a wormhole, gravitational forces play a crucial role in shaping the curvature of space-time and determining the stability of the wormhole. The gravitational forces acting on a wormhole are determined by the mass and energy of the matter that surrounds the wormhole. In order to create a stable wormhole, the gravitational forces acting on the wormhole's throat, the narrowest point in the tunnel, must be balanced so they do not collapse the wormhole. The gravitational forces can be balanced by using exotic matter or negative energy, which generate repulsive gravitational forces that can counteract attractive forces of ordinary matter. However, the gravitational forces acting on a wormhole can also create potential hazards for space travelers. The extreme curvature of space-time near the wormhole's throat can create tidal forces, which are differential gravitational forces acting on different parts of an object. These tidal forces can be so strong that they can stretch and tear apart objects traveling through the wormhole. Additionally, the gravitational forces acting on a wormhole can create significant time dilation effects, which could cause space travelers to experience significant differences in time between the two ends of the wormhole. Gravitational forces play a crucial role in determining the stability and hazards of a wormhole. While repulsive gravitational forces generated by exotic matter or negative energy may offer a potential solution for creating a stable, traversable wormhole, the extreme gravitational forces near the wormhole's throat can create significant hazards for space travelers that must be carefully considered and addressed. Despite decades of research into the feasibility of traversable wormholes, there are still many unknown phenomena that need to be understood in order to determine whether they can be constructed and safely used for interstellar travel. One of the major unknown phenomena is the behavior of exotic matter, which is believed to be necessary to create a stable traversable wormhole. While exotic matter is a theoretical concept, its properties and behavior have not been fully explored or understood, and scientists are still unsure of how to create or manipulate it. Another unknown phenomenon is the potential for quantum effects to destabilize the wormhole. At the quantum level, fluctuations in energy and matter can create instabilities that make it difficult to maintain the stability of a wormhole. Theoretical models suggest that a wormhole might be held open by the Casimir effect, which involves quantum fluctuations of the electromagnetic field. However, more research is needed to understand how these quantum effects might impact the stability of a wormhole. The behavior of gravity at small scales is also not well understood. The current theory of gravity, known as general relativity, breaks down at the quantum level and is incompatible with quantum mechanics, the theory that describes the behavior of matter and energy at small scales. A complete theory of quantum gravity is needed to fully understand the behavior of matter and energy near a wormhole. Additionally, there are many practical engineering challenges associated with constructing and operating a traversable wormhole. These include the ability to create and control the intense gravitational fields near a wormhole's throat, The ability to safely transport matter and energy through a wormhole without being torn apart by its tidal forces, and the ability to establish and maintain a stable entrance and exit point for the wormhole. There are many unknown phenomena and practical challenges that must be addressed in order to determine whether traversable wormholes are a viable means of interstellar travel. While the theoretical concept of a traversable wormhole is tantalizing, more research and development is needed to understand how it might be constructed and safely used for interstellar travel. The concept of traversable wormholes and faster-than-light travel also raises a number of paradoxes that must be considered. One of the most well-known paradoxes is the causality paradox, also known as the grandfather paradox. This paradox arises from the ability to travel back in time through a traversable wormhole. If an individual were to travel back in time to prevent their own birth or the birth of their ancestors, it creates a paradox where the individual's existence is both necessary and impossible. This paradox calls into question the idea of causality and the nature of time itself. Another paradox is the information paradox, which arises from the ability to transmit information faster than the speed of light through a wormhole. According to the laws of physics, information cannot be transmitted faster than the speed of light. However, if a traversable wormhole were created, information could be transmitted from one end to the other instantaneously, seeming to violate this fundamental law of physics. A third paradox is the energy paradox, which arises from the immense amount of energy that would be required to create and sustain a traversable wormhole. According to current understanding, the amount of energy required would be on the order of the entire mass energy of a planet or star, making it seemingly impossible to create and maintain a stable wormhole. Finally, there's the paradox of universes or parallel worlds. It is speculated that if a traversable wormhole could be used for time travel, then it might also be used for the travel between different universes or parallel worlds, which would raise questions about the nature of reality and the existence of multiple parallel universes. The concept of traversable wormholes and faster-than-light travel raises a number of paradoxes and questions about the nature of time, causality, information, energy, and the multiverse. While these paradoxes may seem daunting, they also provide fertile ground for further research and exploration, as scientists seek to understand the nature of the universe and the possibilities of interstellar travel. Overall, while traversable wormholes remain a fascinating area of study, they are still purely hypothetical at this point and would require significant advancements in our understanding of physics and technology before they could ever become a reality. Nonetheless, research into wormholes and their potential applications continues to inspire scientists and researchers to explore the boundaries of our understanding of space-time and the universe. While the concept of traversable wormholes and faster-than-light travel is a popular topic in science fiction, the reality of developing such technology is still very far off, if not impossible. The technical challenges, the unknowns, and the paradoxes make it difficult to predict any specific timeframes for the development of this technology. Some estimates suggest it could take centuries, if not millennia, to develop the necessary technology to understand the fundamental physics involved in traversable wormholes and faster-than-light travel. It's worth noting that the concepts involved are still in their theoretical stages and have not been tested experimentally. Furthermore, the immense energy requirement and technological advancements needed to create and sustain a traversable wormhole are currently beyond our capabilities. It's difficult to predict when, or if, humanity will ever develop the necessary technology to make this kind of interstellar travel possible. That being said, research in this field continues, and scientists are making incremental progress towards understanding the nature of space-time, gravity, and the fundamental laws of physics that underpin our universe. As we continue to learn more about these fundamental principles, it's possible that we may one day develop a deeper understanding of the nature of traversable wormholes and faster-than-light travel, and potentially even develop the technology to make it a reality. While it's difficult to predict any specific timeframes for the development of traversable wormholes and FTL travel, it's clear that significant technological advancements and breakthroughs in our understanding of the fundamental laws of physics will be necessary. As our knowledge and capabilities continue to expand, we may one day be able to unlock the secrets of the universe and journey to the stars in ways that are currently beyond our imagination. Traversable wormholes and faster-than-light travel represent some of the most exciting and intriguing possibilities for space exploration and travel. While the challenges and unknowns involved in developing this technology are significant, the potential benefits are enormous. By allowing us to travel vast distances across the universe in a fraction of the time it would take using conventional propulsion methods, traversable wormholes and FTL travel could open up a whole new era of exploration and discovery. While the development of this technology may still be centuries, if not millennia away, it's clear that continued research and study in this field will be vital to unlocking the secrets of the universe and expanding our understanding of the fundamental laws of physics. As we continue to push the boundaries of what is possible and explore the unknown reaches of space, the potential for discovering new worlds, new life forms, and new knowledge about the universe is truly limitless. And who knows, with time, perseverance, and a bit of luck, we may one day be able to journey to the stars in ways that we currently only dream of. Thanks for tuning in. I hope you found this video informative and thought-provoking. This is the point at which others tell you, if you enjoyed it, please give it a thumbs up and consider subscribing to our channel for more content like this. But, as we all know, that kind of thing is for losers, and you're not a loser. As always, I welcome your feedback and ideas for future videos in the comments section below. Until next time, keep exploring, keep learning, and keep embracing your inner nude, dude.